Welcome to NCERT Class 11 Geography series. This video is on Chapter 9, Solar Radiation, Heat Balance and Temperature. Now it is a well-known fact that we live at the bottom of a huge pile of air. Basically, air is around us all the time. Though we cannot see it, but we can definitely feel it. Let me show it to you with an illustration. Now this is planet Earth. Our Earth is surrounded by atmosphere. So basically this layer of atmosphere does not allow important life essential gases including oxygen to not go out in the space. Similarly, it also doesn't allow harmful excessive sun rays to come inside. And this layer of atmosphere that we just saw, it has some weight and it exerts some pressure on the Earth. That is what is known as atmospheric pressure. Now in the previous chapter, that is chapter 8, Structure and Composition of Atmosphere, in that we came across some list of gases that exist in atmosphere. So here's the list of gases, and the top 3 gases are more in percentage. And I've also told you to remember them specifically, that is nitrogen, oxygen and argon. So anyways, coming to the present chapter, in this we are going to read about how and what leads to heating and cooling of the atmosphere. As I've told you that the atmosphere acts like a blanket that protects the Earth from excessive sun rays, and it also blocks some heat and some life essential gases to go out in the space. And we also know that not every place on Earth receives same amount of heat due to natural tilt in the Earth's axis that causes the sun rays to not reach all the places on Earth equally. Because of this, the amount of heat received by different parts of the Earth is not the same. When temperature is not same everywhere, that causes pressure differences in the atmosphere, that is high pressure and low pressure system. And this further leads to transfer of heat from one region to another by winds. So basically these are the things that we are going to read in this chapter. Let's go to the first topic, solar radiation. The meaning of the word solar radiation is the radiant energy emitted by the sun. Therefore the energy that comes from the sun rays and that is received by the Earth is known as incoming solar radiation. And there's another word to it, it's known as insolation. As I told you before that the Earth is surrounded by atmosphere, therefore this layer of atmosphere works as a blanket. Hence we can also say that this layer of atmosphere intercepts a huge quantity of sun's energy. Now if you see, the sun rays contain a mixture of electromagnetic waves ranging from infrared rays to ultraviolet rays, that is UV rays. Among them, the UV rays are harmful for human beings. A direct contact with UV rays may result in skin cancer, sunburns, etc. So the atmosphere plays an important role by not allowing these harmful rays to come directly into the Earth's surface. So basically it filters it. Now we all know that Earth is a geoid resembling a sphere, meaning the Earth does not have a perfect shape. It has irregular shape. Now here if you see, it says the amount of solar energy reaching the Earth's atmosphere is 1.94 calories per square centimeter per minute. What does that mean? Well, as I said that the atmosphere blocks most of the sunlight, very little portion of the sun rays falls on the Earth. So in the previous chapter, I've explained you that the atmosphere has this 5 layers, right? The outermost layer is the exosphere. So the sun rays first hits the outer layer of the atmosphere, which means all the radiation that reaches the outer layer of the atmosphere, the same amount is not received by the Earth's surface. Because we know that the layers of the atmosphere filters huge quantity of sun rays, basically the atmosphere absorbs most of the sun rays and it also reflects or sends most of the sun rays back into the space. And it is due to this reason the temperature system on Earth is balanced, because we know that the Earth is not very cool nor it is very hot during the entire course of the year. So this was all about how much solar radiation reaches Earth. Now another aspect is that the sun rays that reach Earth's atmosphere, even that varies slightly in a year. You must have seen this picture as in how the Earth revolves around the sun. This is the picture that we have always seen. Here we see the Earth's orbital motion being a perfect circle, but that's not true. It's more of an elliptical shape, where the sun is nearer to one end of the ellipse. So this is the actual illustration of how the Earth revolves around the sun. And one more thing that I want to specifically mention is that when Earth travels one entire trip around the sun, it does not return to the same starting point. There is a deviation in the elliptical path after the Earth has completed one revolution around the sun. And the reason behind this deviation is a result of the gravitational attraction among other planets. You see, after all, every planet is revolving around the sun. And then there are planets like Jupiter and Saturn. They are much bigger than Earth. Hence, their moving patterns around the Sun, in other words, their elliptical path, has some effect on Earth's elliptical path. That is why the Earth, after completing its one revolution, never returns to the same starting point. And also this is the reason behind coordinating our calendar with the Earth's motion, which gives us a leap year. If I have to tell you this concept in the most simplest manner, then just remember this. Earth is not exactly at the same spot in its orbit on your birthday every year. I hope this concept is clear now and you have understood the Earth's motion around the Sun. Now the speed of the Earth in its elliptical orbit is maximum when it is closest to the Sun. And when it is far, the speed is minimum. So here you can see that during the month of July, that is 4th July, the Earth is farthest from the Sun. This position of the Earth is called aphelion, wherein we are 152.6 million kilometers away from the Sun. And on the other hand, on 3rd January, the Earth is nearest to the Sun, and this position is called perihelion, wherein we are 147.5 million kilometers away from the Sun. Hence, we can conclude that the annual insolation, that is the incoming solar energy or sun rays, is more on 3rd January and incoming solar energy is less on 4th July of every year. Please remember these dates. So this is the theory part. Now in reality, you will not see the effect. I mean to say, on July 4th, you will not feel that the heat is less, or maybe on 3rd January, you will not feel that the day is very warm. You will not feel any of those variation. And the reason is pretty simple, because all this theoretical part that I just spoke about, it does happen in reality, but then it gets hidden by other factors like the temperature distribution of land and sea, as we have seen that land and sea has differential heating pattern, then atmospheric circulation, that is high pressure and low pressure events. So these factors actually hide the effect of insolation caused by aphelion and perihelion on Earth's weather. Now we'll read about the variability of insolation at the surface of the Earth, meaning what changes does the incoming solar energy has on the surface of the Earth. Now here it says the amount and the intensity of insolation varies during a day in the season and in a year. Because you see, you don't feel very warm the entire day, right? Probably in the afternoon it gets very warm. Otherwise in the morning and in the evening it's fairly cool. Similarly, we have 4 different seasons, that is summer, winter, monsoon and spring. And it is only during the summer days it gets very warm. Otherwise in rest of the season it's not that warm. So clearly we see that there is a variation in the incoming solar rays. Now the interesting thing would be, what is it that causes the variation in incoming solar rays? Well, we have actually 5 reasons behind it, and they are: the first one is the rotation of Earth on its axis. So here we are talking about the rotation, not revolution. It takes 24 hours, actually it takes 23 hours and 56 minutes for the Earth to rotate on its own axis, because of which we witness day and night. And that also brings temperature variation because at night it's fairly cool than day. The second reason is the angle of inclination of the sun rays. You must be familiar with this picture. In this picture we clearly see that the sun rays are direct and extreme at the equatorial region, that is the central region of the Earth. Now as we go away from the equator towards the poles, the sun rays are at lower angles, and that's what is the reason behind temperature differences. You see, as we go away from the equator, both in the northern and southern hemisphere, the temperature decreases. The third reason is the length of the day. Now the length of one day on Earth is determined by how long it takes the Earth to rotate once. So moments back I've told you that the Earth takes 23 hours and 56 minutes to rotate, and that's how it determines day and night factor. And for comfort, we usually divide that approximate 24 hours in 12 plus 12 hours basis, in which 12 is given to daytime and 12 is given to nighttime. But then you see, that's not exactly true. Sometimes the day is longer than night and sometimes the night is longer than day. And it totally goes back to the fact that at what angle the Earth's axis is rotating at. So if you remember this pic, it's called the winter and summer solstices. In this you can see, due to the changes in Earth's axis, or we can say tilt, there is a change in the duration of the length of the day in hours and minutes on winter and summer solstices, about which we will read in a while. The fourth reason is the transparency of the atmosphere. Now we know that the Earth's atmosphere happens to be essential to life. The transparency of atmosphere means how much of the atmosphere is clean enough to be clearly visible. Now, for example, what if there is a volcanic eruption or forest fires that will make the atmosphere translucent or opaque? This will definitely block the incoming solar radiation, and to a lot extent it will also block the extra radiating heat of the Earth's landmass to go out in the space. I mean, that is what is causing climate change. And the fifth reason is the configuration of land in terms of its aspect. When we hear land, we mean topography, that is the land masses or continents on which various physical features exist. Now, the reason behind increase in landmass affects temperature of the surface of the Earth is by understanding the fact that landmass heats up faster than ocean bodies. This would in turn increase the overall Earth's temperature because the heated landmass radiates heat, and we have read moments back that one of the roles of atmosphere is to block the heat from going out completely into space. So I hope you're getting the role of landmass when it comes to Earth's temperature. Now here it says, the fact that the Earth's axis makes an angle of 66.5 with the plane of its orbit around the Sun has a greater influence on the amount of insolation received at different latitudes. If you look at this picture, you can see the manner in which the Earth is tilted. It's not like the equator is absolutely straight or linear with respect to the Sun. It is always in this angle, 66.5 degree, remember this. Now, due to this position of the Earth in its own axis, the amount of sun rays falling on Earth's surface varies with latitude. Now, during summer solstice, that is in the month of June, the northern hemisphere is tilted towards the Sun, and the northern hemisphere receives more sun rays. That's why it's summer in the northern hemisphere in the month of June. Now, as the Earth moves around the Sun, it then reaches the next stage, which is autumnal equinox. This is in the month of September. At this stage, both the hemisphere receives equal amount of solar energy. Always remember, at equinox, day and night of Earth is of same length. Going further, the Earth now moves towards winter solstice, which is during the month of December. If you remember, in summer solstice, the northern hemisphere was tilted towards the Sun. The position remains the same, but in winter solstice, the southern hemisphere is more exposed to the sun rays. That's why the southern hemisphere receives more solar energy in the month of December. You must have also heard that in Australia, Christmas is celebrated during summer. Now from winter solstice, the Earth moves towards vernal equinox. This is in the month of March. Again, just like autumnal equinox, even in vernal equinox, both the hemisphere, that is the northern and southern hemisphere, receive equal amount of sun rays, and the length of day and night is the same. Now let's read about the passage of solar radiation through the atmosphere. As we have read that between the sun rays and the Earth's surface, there's a large transparent atmosphere, which of course consists of several layers. Now it is this atmosphere that filters the sun rays, and it is also this atmosphere which prevents all of the heat from the Earth's surface to escape out in the space. So in a nutshell, atmosphere is very important for all the living organisms on Earth to survive. We have also read about the 5 layers of atmosphere. In that there's a layer called troposphere. Within that, water vapor, dust particles, ozone and other atmospheric gases exist. So when solar energy passes through the layers of the atmosphere, it also passes through these atmospheric gases, water vapor and dust particles. While making its way to the Earth's surface, some of the solar energy is consumed or absorbed by these atmospheric gases, water vapor and dust particles. Now the moment sun rays passes through these atmospheric gases, water vapor and dust particles, sun rays scatter, causing some color effect like blue sky, then red color of the rising and setting of sun. So always remember, the color of the sky is a direct result of scattering of sunlight within the atmosphere. The rest of the chapter has been concluded in the second part of this video.